1.5 minutes, it becomes constant, and that describes the data well. So I feel like my final answer would be B.
Mhm. Okay. So I think that you had very good start to these answers, and you're right. This is equilibrium, so we're always talking about even though that the pressure is constant, you could still have things going back and forth, but there's no net change because whatever is turning into the gases and causing that pressure could also become condensation and go back into the liquid. So I think you have a good grasp of that concept, which is definitely for equilibrium. Um, let's see. So you were kind of between B and C, but you're going mostly to B. Is that correct?
Yes.
Okay. So B says the acetone has completely vaporized after 1.5 minutes, so the pressure becomes constant. So the question says at the end of 2 minutes, some acetone liquid remains in the container. So
Okay.
because of the information given in the question, I feel like B assumes that it's completely vaporized, but we're given that actually there's some liquid remaining. So that just tells me that the equilibrium isn't necessarily where everything's vaporized, but rather it's at a state where you have some liquid, but you also have gas and you have, liquid turning into gas and gas turning into liquid at the same rate. And that's what causes that equilibrium and that pressure to stay constant. Does that make sense?
Yeah, that makes sense. So would the rate of condensation be like the forward rate,
Mm-hmm.
and then the evaporation would be the reverse,
Mm-hmm.
or something like that?
Yeah, so I agree with C being the correct answer because let's just break down the answer choice. So it's saying that acetone vaporizes from the liquid at a constant rate. So that's just saying that the rate of vaporization is staying constant. And then the rate of condensation increases until it becomes equal to the rate of evaporation, and then the pressure stays constant. So let's think about what it means for the rate of condensation to increase.
I feel like pressure is more when like it evaporates, and then that's how the pressure like increases, and then I would assume that like the condensation like will balance it out.
Mhm.
So the increases until it becomes equal. So I guess that's what's happening here, is that it's like constantly condensing and evaporating to keep it balanced.
Yeah. So I think for this question, C is definitely is the best answer that I'm seeing. Because A is just saying causing more of it to vaporize as an increasing rate. That doesn't really capture the data that shows that the pressure is staying constant after 1.5 minutes. So I think A is not the best answer for sure. So good that you ruled that out. And then for D as well, until the vaporization process stops completely. We know that equilibrium, just because it's staying constant, doesn't mean that it's stopping completely. So definitely A and D, you did good in ruling it out. But I think between B and C, I think to rule out B, you kind of had to go back to the question, if that makes sense.
Yeah, that makes sense. Okay. Yeah, I feel good about this question then.